Okay, so today we're solving equations, but this time it's going to have variables on two sides of the equation instead of just one. So this is very similar to everything else we've been doing, it's just one extra step. So make sure that you are again adding the date and the page number that you're on, and then you're adding all this information into your table of contents, and then don't forget to write down your learning target. So for example 1, we are going to draw our line down the middle like we have been every time, and we're going to follow the exact same steps that we did before. So the first question we ask ourselves is, can I distribute? No, there's no distributing on either side. Can I combine like terms? No, these are not like terms. This has no other terms. The next step says move all your variables to the same side. Well, right now they're on two different sides. So what I'm going to want to do is I'm going to want to get them all on the same side. So, when I look at these two variables, you can decide which side you want to move them to. It doesn't matter. So I personally would rather move this one over here. That way the plain number is on one side and the variable is on the other side. Because you don't want to be left with nothing over here. So I'm going to get rid of 7x. In order to get rid of it, I'm going to subtract it, take it away, because I need this to go to 0. 7x minus 7x is 0, and I'm left with negative 9 only on this side. Here I've got 4x minus 7x, which gives me a negative 3x. So now I need to box my variable and do inverse operations to get isolated. So this variable is now by itself, but I need to get rid of negative 3. So to take the negative 3 off of there, I would need to divide by negative 3. You do it to both sides, and negative 9 divided by negative 3 is a positive 3 equals x. So my answer is 3 equals x or x equals 3. It doesn't matter which way you write it. Either way it means the same thing. You're saying that they're equal to each other. Alright, example 2. Same thing. Draw your line down the middle. And I'm going to look for distributive property over here. And I don't have any. I don't have distributive property here. So that's taken care of. Now I'm going to look for like terms. I don't have any over here. And I don't have any over here. So that's taken care of. Each side of the equation has now been simplified. But I do need to look, and I see, look, I've got variables on both sides. So I need to move them all to the same side. And it doesn't matter which way you go. I personally, in this case, would move the 2x. Because if I moved the 5x, then I would end up with a negative. But it doesn't matter. You can't get a wrong answer doing it the other way. So in order to get rid of positive 2x, I subtracted it so that this goes to 0. The only thing left over here is 14, so I'm going to bring it down. And over here I've got 5x minus 2x, which is 3x. And then I didn't touch the plus 2, so it just comes down. Next step says to box your variable. Well, there's my variable. And I need to move everything to the other side, so I'm going to move this plus 2 away from it. So I'm going to subtract 2 to get rid of it, because I want this again to go to 0. This would leave me with 12 on this side, and the only thing left on this side was a positive 3x. My next step will be to get rid of 3, and that's 3 times x, so to undo it, I'm going to divide by 3. And I get x equals 4. So x equals 4 is my answer. Example 3. Now I've got a few more steps to do. First question, can I distribute? And I can on both sides. So I'm going to focus on one side at a time. And I'm distributing 2 times everything inside parentheses. So 2 times 5x is a 10x. And 2 times negative 1 is a negative 2. On the right side, I can distribute. So I'm going to go ahead and do that as well. 3 times x is 3x, and 3 times 11 is 33. Next question, do you have any like terms? No, I cannot combine like terms over here, and I cannot combine like terms over here because they're not like. They don't both have x's on them. So the next step are all my variables on the same side, and they are not because I have a 3x over here and a 10x here. So I'm going to move them. And again, this time I'm going to move the 3x over here. It really doesn't matter. You could move the 10x, but I don't want a negative. So I'm going to subtract 3x. And when I do that, 10x minus 3x is 7x. Bring down the minus 2 that I didn't touch. 3x minus 3x goes to 0, which is why I subtracted it. And then I bring down the 33 that I didn't, the positive 33 that I didn't touch. Next step, box your variable. Get rid of everything else around it. So I'm going to have to get rid of minus 2. In order to do that, I'm going to add 2. So the only thing left on this side is 7x because negative 2 plus 2 goes to 0. And then I've got 33 plus 2, which is 35. My final step is to divide both sides by 7. And 35 divided by 7 is 5. So my answer is x equals 5. Final example. Draw your line down the middle. Again. First step, can I distribute? And I can on both sides, again. But this 5 is only going to these two terms. I'm not touching this 2 because these two terms are in parentheses. And this 2 is going to go to these two terms. So I'm going to go ahead and do my distributing. 5 times 2x is 10x. And 5 times positive 2 is a positive 10. Notice there's a plus 2 here that I didn't touch, so I need to make sure that I bring down. I didn't multiply it times this 2 because it wasn't inside the parentheses. The other side, 2 times 5x is 10x again, and 2 times 6 is a positive 12. Okay, next step says, can I combine like terms? And I can on the left side. These two are like terms. I can't over here because I don't have any like terms. So I'm going to combine those like terms and get 12, and it was a positive 12. And I'm going to bring everything else down, the 10x, the equals, this side had a 10x, and this side had a 12. Next step, variables to the same side. Here's a variable, and here's a variable. So I need to move them all to the same side. It doesn't matter which side you move. So I'm going to get rid of 10x, and I'm going to subtract it. Now when I combine those, that's 0. So on this side I'm only left with 12. And that's 0. So on this side I'm also only left with 12. All my x's are gone, so I can't get x equals something. So in this case, I'm either going to get something that's called no solution or infinitely many solutions. And to tell you that answer, you're going to ask yourself, is this true? Does 12 equal 12? And it does. So it's infinitely many solutions. And what that means is you can pick any number you want to and plug it in for x in this original problem, and you will get the right answer either way on either side of the equation. You won't get anything crazy. So any number, x is every number. X, anything you plug in for x, anything you pick will work in this equation. Whereas, for example 3, that wasn't the case. The only thing that will work in this equation is when x equals 5. Same thing when you get anything x equals. So an example of when it would be no solution is if I solved all this out and got something like 12 equals 2. That's not true. So my answer in that case would be no solution. So if your x's cancel, you end up with either no solution or infinitely many solutions. But in this case it's infinitely many because again 12 does equal 12, it's true. So make sure that if the question doesn't pop up and it doesn't let you answer it, that you at least rate the video with one of those smiley faces, or you give me some sort of feedback as like where it asks you why did you give it this score. Make sure that you write something so that I can see that you did watch the entire video.